Welcome to BSc Statistics students. In this lesson, I discuss one more problem of the simplex method. Previously, we did one problem, the simplex method, and this is the second problem. We do the one more problem. This is the problem of maximization. Maximize z is equal to this. It is the objective function, and the constraints, three constraints are given here, and x1, x2 greater than or equal to 0. To finish fast, to complete in some particular two parts. So I want to explain the problem, one or two parts. I want to explain the problem so that I have drawn simplex table 1 and simplex table 2. I have prepared already, right? So now come over here. What are the basics to be considered here? So first we have checked whether the objective function is maximization or minimization. Here it is maximization, therefore no problem, continue. Next in the next step we have to check whether all bi's, right hand side constants, bi's are non-negative or not. So that we have to check it. So all are greater than or equal to 0, non-negative, therefore go to the next step. Right, so then we have to introduce slack and surplus variables, whichever necessary in the problem, so that inequations of the constraints are to be converted in terms of equations. So what I am doing now, I am starting with that. All less than or equal to constraint. So therefore, introduce slack variables. Therefore, 2x1 plus x2. I am introducing, this is less than or equal to. I am introducing another variable called slack variable x3. x3 is equivalent to be 40. Similarly, for the next constraint x1 plus x2, and I am introducing already x3, therefore I am introducing x4, the slack variable, and I am converting as in terms of equation. And similarly, next one, third constraint, 2x1 plus 3x2 and plus x3, x4 we have already introduced, hence I am introducing x5, is equivalent to be 60. So this is what the introduction of the slack and surplus variables, and then converting inequations into equations, right? So now whatever the variables you specify, where x3, x4 and x5 which are greater than or equal to 0 are slack variables, and then what you have to do, and then we have to introduce the cost of these functions, put the cost of these variables, slack variables as 0 in the objective function. Therefore, modified objective function, it is going to be specified as z is equivalent to be maximize z is equal to 3x1 plus 2x2 plus 0 into x3 plus 0 into x4 plus 0 into x5. This is what the modified objective function. Introduce or put the cost of the slack or surplus variables as zeros, 0 into x3, 0 into x4, 0 into x5 in the objective function, so that you modify the objective function. Now this is the object, this is what the objective function. Now you have to write, you write the matrix form. So I am not specifying here. You write the matrix form so that I am specifying the initial basic feasible solution. So I just tell you the matrix form. A 2 1 2 1 1 3 1 0 0 0 1 0 0 0 1, that is A. B, okay, I write here the matrix A is equivalent to be 2 1 2 1 1 3 1 0 0 0 1 0 0 0 1. This is what the matrix A, and then what is X? It consists of 5 variables now. Original variables are x1, x2, slack variables are x3, x4, x5. So hence x is equal to, it is a 5 by 1 vector, column vector, and the right hand side constant B, it is 40, 24 and 60. This is what the right hand side constant vector B. This is what the matrix form. What is the matrix form? Ax is equal to B. The matrix form is Ax is equal to B. I explained in the last class, so I am leaving. Now, what you have to consider, the initial basic feasible solution xb is equal to b inverse b, for which we have to write b. So I am writing here b. B is equivalent to B. What is B? B is here the unit matrix are the matrix which are in the basis. That is here you see it is y1, it is y2, y3, y4, y5. So y3, y4, y5. It is the basis matrix in which we have to write here 1 0 0 0 1 0 0 0 1. You understand? Whichever the vectors which are in the basis, we have to write that is called the basis matrix B. So now by using B, we are calculating XB, the initial basic feasible solution. That is the next important point. So whether you write all these things is not the problem, but you have to write the initial basic feasible solution. What is the initial basic feasible solution? The initial basic feasible solution. The solution of this particular problem is XB is equal to B inverse B. Now you calculate XB is equal to B inverse B 1 0 0 0 1 0 0 0 1. So inverse again same unit matrix. B is 40 24 60. So please multiply it 40 24 60. So this is what the value of XB, which means what is XB? I write XB here. XB is equal to X3, X4, X5. So you have to understand both the things. Now, what is XB? The values of X in the basis matrix. The values of X in the basis matrix. What are the values of X in the basis matrix? What are the vectors in the basis matrix? Y3, Y4, Y5. So, corresponding to Y3, the value of the variable is X3. Corresponding to Y4, the variable is X4. Corresponding to Y4, the variable is X5. So X3, X4, X5, that is XB. It is nothing but basis now. And the values, the variables in the basis matrix are X3, X4, X5. Therefore, X3 is equal to 40, X4 is equal to 20, X5 is equal to 60. Now I say, again I recollect the definition of basic solution. So, the initially, what are the variables are there in the problem? X1, X2. By putting the values of X1, X2 are zeros. Now, the values of X1, X2 are zeros. And by considering the values of X1, X2 zeros and solving the resulting system of m variables is nothing but the problem. That is basic solution. That is called basic solution. Recollect the definition. I am recollecting the definition. So, this is what the initial basic feasible solution. Put in the first column of the simplex table. So, this is what the next step. Obtain an initial basic feasible solution and put in the first column of the simplex table. What is the first column of simplex table? XB. So, you write down, that is take this particular vector and put in the first column of the simplex table. Write in the first column of the simplex table. It is 40, 24 and 60. This is what the first column of the simplex table. I am entering to the simplex table 1. So, hope you understand, this is simplex table 1. Simplex table 1, I am taking this particular initial basic feasible solution and remaining values you can write. Remaining all with help of the vector or by seeing the constraints. So, come to the, I have written the vector. So, please note down the vector here. That is y1. How many vectors are there? y1, y2, y3, y4, y5. There are 5 vectors. What are the costs? Here the cost function, that is equal to 3x1 plus 2x2 plus 0 into x3 plus 0 into x4 plus 0 into x5. So therefore this is nothing but c1x1, c2x2, c3x3, c4x4, c5x5. So c1, c2, c3, c4, c5. The costs. What are the costs here? 3, 2, 0, 0, 0. This is what from the objective function. It is obtained. Cj is the cost. Cj is the cost vector, or it involves the cost of all the variables. It is nothing but the coefficient of cost. That is C1, C2, C3, C4, C5. Coefficient of cost matrix. That is what we are specifying. That C. So Cj we have specified. Now remaining values. The vectors y1, y2, y3, y4, y5. So 2, 1, 2. And 1, 1, 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So, what are the values of, that is vectors of basis matrix? Y3, that is the first one, 1, 0, 0. I am writing first. Y4, 0, 1, 0. Next, Y5, 0, 0, 1. Right? So, next we have to fill this. And then cost. Y3 cost is 0, Y4 cost is 0. Wi-Fi cost is also 0. So this is what the fill up the first simplex table. This is the way of filling the first simplex table. Writing the or constructing the first simplex table. Do you understand this? Now and then you have to calculate the value of Z. Z the formula is, I am erasing all this. Z the formula is the formula of Z. The formula of Z is equal to CBXB. So use the formula and calculate Z value. Thereafter we have to calculate all the values Zj minus Cj. Z is equal to formula CB into XB. What is CB? This is CB. What is XB? This is XB. So you multiply these two, 0 into 40 plus 0 into 24 plus 0 into 60. It is 0. You indicate here, so it is 0. So next, Zj minus Cj. The formula is CB Yj minus Cj. This is the formula of net evaluations. What is Zj minus Cj? Net evaluations. You calculate net evaluations for each and every vector y1, y2, y3, y4, y5. That is the reason why I have taken double line here. After that, you have to calculate all the values of Zj minus Cj. This is only you have to calculate Z by using CB, XB. So now CB by Z, 0 into net evaluations for y1, 0 into 2, 0, plus 0 into 1, 0, plus 0 into 2, 0, minus 3. So it is minus 3. And plus 0 into 1, 0, 0 into 1, 0, 0 into 3, 0, minus 2, it is minus 2. So therefore, now, next one, y3, 0 into 1, 0, 0 into 0, 0, 0 into 0, 0, 0 minus 0, 0. This is 0, this is also 0. You calculate it, right? With the help of the formula CB Yj minus Cj, you multiply 0 into 1 plus 0 into 0 plus 0 into 0. After adding all this and the CB Yj, which means CB Yj, and then minus Cj, minus cost Cj. I have written clearly Cj. Do that, and after that, what you have to calculate. So now, after calculating the net evaluations, we have to check whether if all Zj minus Cj are greater than or equal to 0. If not, you see here, no, it is not greater than or equal to 0. So some are negative are there, some values are negative. So if only one negative, you consider that. Otherwise, if at least one negative, Zj minus Cj, if any of Zj minus Cj is negative, then what you have to do is you have to go to next step and you have to consider that the most negative net evaluation Zj minus Cj. You have to consider most negative net evaluation Zj minus Cj. What is that? Minus 3, minus 2. Most negative, minus 3. Now, you see the corresponding vector y1. Here it is y1. Therefore, you write down immediately. Therefore, y1 enters the basis. Enters the basis. That is what you have to write. After that, what you have to do? You have to see all the values of y, the elements in the vector, that is in the vector. It is going to be considered. It should not be less than or equal to less than 0. If all values are less than or equal to 0, if all y are less than or equal to 0, the current solution is unbounded solution. If at least one y are greater than 0, if at least one y are is greater than 0, then only next problem continues. So now you see here, if all y are, which is here, it is greater than 0. So therefore, no problem. Now we have to continue the next further procedure. What is the further procedure? In case of at least one y are is greater than 0, then we have to consider minimum ratios. What are the minimum ratios? The formula. The minimum ratios, minimum of xbi by yir, where yir must be greater than 0. This is what the procedure is equivalent to be. The minimum of xbi by yir. You see, this is xb, this is yir. That which means which vector is going to enter the basis, for which you have to consider y1r. That is 40 by 2, 40 by 2, 24 by 1, 60 by 2. Remember, just not finding the minimum ratio, it is important. Also finding the vector and element corresponding to that particular element, corresponding to that particular value, it is important. 40 by 2, 20, this is 24, this is 30. 60 by 2, 30. So 20 is the minimum ratio. So 20 is the minimum ratio. Corresponding to which element? This is 2. That is important. Remember, you have to identify the element. The element itself, it is pivotal element. The element directly gives the pivotal element or leading element. So therefore you consider the 2. That is, you mark the 2 in this particular simplex table 1. In the simplex table, that is, I am putting star round off the value, so that the 2 is pivotal element. Before that, what you have to be corresponding to 2, which vector you have? Y3. Therefore, Y3 leaves the basis. Leaves the basis. That you have to write. Y3 leaves the basis. Now you have to see the corresponding element 2. That is the common element. The one vector is entering, y1 entering the basis and y3 leaving the basis, for which it is a common element. For y1 and for y3 it is a common element, that is called pivotal element. That is called yk leaves the basis, yr enters the basis, for which it is a common element at yk, or it is called the pivotal element or leading element. The leading element is now 2. Therefore you write down, therefore 2 is pivotal element. 2 is pivotal element. That is what you have to write. 2 is pivotal element. So you have to, what you have to do after the simplex table 1, that is after simplex table 1 simplex table to another simplex table. Of course row operations are there, we do it later on. So from one simplex table to another simplex table, what you have to remember, the key points are y1, which vector enters the basis, and you have to calculate minimum ratios, which vector leaves the basis, what is the pivotal element, and one more is row operations. These are the 5 important points you have to see. Whether for all the simplex tables you don't have a row operations, at the last simplex table you don't have it, but it is the procedure. Procedure is nothing but, so which vector enters the basis, we have to see from one simplex table to another simplex table, which vector enters the basis, which vector, and we have to calculate minimum ratios, which vector leaves the basis, and pivotal element, which is the pivotal element, and finally you have to calculate some relevant row operations. These are the 5 important points from one simplex table to another simplex table that is required to find out. So now what I am calculating, that I am indicating one more indication here, arrow mark, that y3 leaves the basis. Y3 leaves the basis and y1 is going to enter into the basis. So therefore I am going to the simplex table 2, and then I do the row operations there. Right? So therefore I am entering to the simplex table 2. Here I have prepared simplex table 2. I have to consider the vectors y1, y2, y3, y4, y5. I have considered cos. I put the cos. I write the cos because which are as usual. Right. Now from simplex table 2 onwards, remember the simplex table 2 onwards, first entered column is yb. First you have to write yb. In the simplex table 1 it is different. I have explained clearly. You have to write xb first, and then remaining all. You have to, whatever it is the order, it is not important, you can fill all the values. Now from the simplex table 2 onwards, the very important thing is you have to write first of all yb, because it has some particular changes. Definite changes are required or needed there for yb. So therefore I am converting, I am writing the values of yb first of all. Whichever the changes which are there, the changes which one particular vector enters, one particular vector leaves. So which is entering? Y1, in the place of which, that is, which is leaving? Y3. So therefore y3 leaving, y1 entering, that is in the place of y3, y1 I entered. That is what the first, only one, of course. The one of the important change which is required for simplex table 2. Next simplex table, that is what? And y4, y5 as it is. Y4, y5 as it is. Now you can write the cos. Y1 cos 3, y2, y4, y5 cos are zeros. Okay. So now I write I have xb, from xb onwards y5. You have to calculate with relevant row operations. xb onwards, xb also a vector. You have to do relevant row operations. So therefore xb onwards, remaining all vectors y1, y2, y3, y4, y5, which are all we have to change with the help of the row operations, relevant row operations. We have to make changes. So I am writing here r1, This is R2, this is R3 from the simplex table 1, and I write here R1 dash, R2 dash, R3 dash. These are the considerations I am considering for row operations, relevant row operations I am considering rows. The name, I am naming the rows. I give the names for rows. So now you have to see the operations. I am arranging this, and so that I write the values of y1, that is row operations. First of all, which row it is going to be entered? R1 dash. So therefore, first of all, we have to write R1 dash. This is what? R1 dash is nothing but what is the element we have to convert? Unity. You see here, this is row operations are based on two particular important things. Convert the leading element to unity, and remaining all other elements are zeros. Which means you have to convert this leading element 2 as unity. That which means you have to divide it with 2. That is R1 divided by 2. And remaining all other elements are zeros, 1 and 2. That is in 1 in R2, 2 in R3. You have to convert as zeros. Okay. So just I write the operations and do in the next particular part, because it is going to be a long period. Right. So now we come over here, R1 divided by 2. R1 dash is R1 by 2. So you write R1 by 2. That is 40 by 2, 20. So 2 by 2, it is 1. It is 1 by 2. It is again 1 by 2. It is 0, 0. And R2 dash. What is R2 dash? I write the operations. What you are do? Plus R2 immediately. Plus R2. Okay, right? And what you have to multiply? R1 dash. Always R1 dash. That is this, which was entered into the first entered row. That you have to consider first. And you have to multiply with, here it is 1. Therefore, you have to multiply with minus 1. Minus 1 into R1 dash plus R2. That is what you have to do. Similarly, I write one more operation. I write the operation here. R3 dash. Actually, I have right here. Okay, I write here R3 dash. It is nothing but again plus R3. What you should not make any particular differences. Minus R3 you should not consider. Then basis will be changed. That is basic important point in this consideration of the row operations. Right? That is the reason why it was specified relevant row operations. Which are not relevant, you should not consider. So therefore, you follow one particular pattern I am indicating here, plus R3. Which particular row you have to multiply? R1 dash. So R1 dash. What is the element here? You have to convert for R3. It is 2. Then you have to multiply with minus 2. That's all. Okay. I do the operations in the next part. Thank you.